Good morning. Today's class about continuous random variable. A continuous random variable Ex, if it takes all possible values between certain limits or in interval which may be finite or infinite. So we can say there are infinite number of outcomes. It is called the examples of the continuous random variable. For example, the density of milk taken for testing at a farm. So we cannot able to say the exact values. The operating time between two failure of a computer. So it can be a uncountable number of random variables. So infinite number of random variables. So this is the examples of the continuous random variable. There are four formulas. Probability density function PDF is equal to minus infinity to plus infinity f of x into dx is equals to 1. So the previous video we have seen the about a discrete random variable. For discrete random variable it is probability mass function PMF. Here continuous random variable it is probability density function PDF. So the formula minus infinity to plus infinity f of x into dx is equal to 1. Mean is equal to E of x is equal to minus infinity to plus infinity x into f of x into dx. E of x square equal to minus infinity to plus infinity x square into f of x. Then variance of x is equal to E of x square minus E of x the whole square. Cumulative distributive function CDF is equal to capital F of x is equal to P of x less than or x. Formula minus infinity to plus infinity f of x into dx. So these four are the basics of the continuous random variable, and the properties of expectation, variance and the properties of CDF is the same property for continuous random variable. Now the first question for the continuous random variable. So now if P of x is equal to x into e to the power minus x square by 2, x greater than or equal to 0, show that P of x is a probability density function, find its distributive function, which means find the CDF. So the first question is find PDF, the second one is find the CDF. Here P of x, here f of x, instead of f of x, P of x, x into e to the power minus x square by 2, x greater than or equal to 0. If it is 0, the value x less than 0. So first of all, we can find the value of PDF. So if we have the formula minus infinity to plus infinity, P of x into dx is equal to 1 if the probability density function. So there are this interval given limits, we can take it as a 2 integral minus infinity to 0 and 0 to infinity. Now minus infinity to 0, because if the value x less than 0, the given condition is P of x is equal to 0. So minus infinity to 0 is equal to 0 plus x greater than or equal to 0. So we can assign the value of x is equal to 0 to infinity P of x into dx. Now this is 0, so the entire integration is 0. Now the second integration 0 to infinity P of x into dx. This we have to integrate using substitution method or any integration by parts, because there are two functions of x given. If there are two functions of x, use the Bernoulli's formula for integration or any substitution method or integration by parts. So any method we can apply for this integration. Suppose that a substitution method, if x square equal to t, then differentiation of x square equal to 2x. So differentiate with respect to x. 2x into dx is equal to dt. Therefore, x into dx is equal to dt divided by 2. Because of here, the question is x into dx. So the value of x into dx is equal to dt by 2. And the limits are given x is equal to 0 and x is equal to infinity. If you take x is equal to 0 in this, t equal to 0. If x is equal to infinity, substitute here, t is also infinity. So x is equal to 0, t equal to 0, x is equal to infinity, t equal to infinity. So there is no changes in the limit. Hence, So this question minus infinity to plus infinity p of x into dx is equal to, this is the remaining interval. This interval can be changed into the t limits as t equal to 0 to t equal to infinity. E to the power x square, we have x square substitution is t, so e square e power minus t by 2 into, what is the substitution of x into dx? X into dx is equal to dt by 2. So now take the constant of 1 by 2 e to 0 to infinity integral e to the power minus t by 2 into dt. So the integration of e power ax is equal to e power ax by a. So the integration of minus e power minus t by 2 is equal to e power minus t by 2 by the coefficient of t is equal to minus 1 by 2. So e power minus t by 2 by minus 1 by 2, and already we have the constant of 1 by 2. This 1 by 2 we can get cancelled. So this minus is the common, as e t is equal to infinity, upper limit e to the power minus infinity, minus of minus, already we have the minus is there, so minus into minus plus, as t equal to 0 is the lower limit, so e power 0. E power 0 is equal to 1. E power minus infinity, it is 0, so here it is mentioned. So e power 0 equal to 1, so the answer is 1. Hence the PDF is equal to 1. Hence, the question is, we have to show the given probability density functions. The given question is probability density function. We have the answer also 1. Hence, the given probability density function is exactly correct. Hence, the function is PDF. The second question is the probability distributive function, which means CDF. Capital F of x is equal to P of x less than or equal to x. So 0 to x, P of x into dx. So 0 to x. P of x, it is x into e to the power minus x square by 2 into dx. So just now we can use the same substitution of here, x into e to the power minus x square by 2 into dx already we found, and in upper limit is equal to, here it is instead of infinity equal to, instead of here x. So after we using the integration and use the same technique for the previous one, we have the answer e to the 1 minus e to the power minus x square by 2, 0 to infinity, or x is equal to greater than or equal to 0. So this is the problem for the continuous random variable. So in this way, we can see the another question. A continuous random variable PDF f of x is equal to 3x square, where 0 less than or equal to x less than or equal to 1. Find the a and b such that first solution p of x less than or equal to a and p of x greater than b. First sublution, it is given p of x greater than a. Second sublution, p of x greater than b, which is equal to 0.05. So using this condition of first and 2, we have to find the constants a and b. So first of all, p of x less than or equal to a greater than p of x greater than a. Now x less than or equal to a. So x less than or equal to a. So the limits are 0 to a. 0 to a is equal to, now f of x into dx, given f of x is equal to 3x square into dx. So already 0 to 1 given, but here x less than or equal to a. So upper limit instead of 1 equal to, we have to take it as a. So 0 to a, 3x square into dx, which is equal to x greater than a. Now x greater than a, so the limit is from a to infinity, but here actual limit for upper limit is up to the limit is 1. So a to 1 f of x into dx, f of x it is 3x square, so 3x square into dx. So after the integration of this, now 3 into x square into dx, x cube by 3, 0 to a. Now here this f of x into dx, f of x is given 3x square into dx, so x cube by 3. Now so 3 into here upper limit minus lower limit, so 1 to a. So now here this is 3 after cancel this 3 x cube is equal to upper limit of x is equal to a, so a cube minus 0. So a cube minus 0 is equal to, here 3 cancelled, it is x is equal to 1 is the upper limit, so 1 cube minus a cube. So now a cube is equal to 1 minus a cube. Now this minus you bring it to the left hand side, 1a cube plus 1a cube, 2a cube is equal to 1. Hence a cube is equal to 1 upon 2. What is a? 1 by 2. take the cubic root of this. So 1 by 2 whole power 1 by 3. So after we taking the cubic root of this 1 by 2 is equal to 0.7937 is the value of A. Next we can go for the another constant to find the constant B using the second condition. The second condition x greater than B equal to 0.05. So x greater than b, as per the x greater than b is b to infinity, but here the limitation upper limit is equal to given question. So b to 1 x square into f of x into dx, f of x is equal to 3x square into dx, which is equal to the answer already given 0.05. And now the integration of 3x square, 3 into x cube by 3. So 3 cancelled, it is x cube by x is equal to 1 is the upper limit, minus x is equal to b is the lower limit. So 3 after cancellation of this, 1 minus b cube is equal to 0.05. Hence b cube is equal to, you can bring it to the 0.05 values into this left hand side. 1 minus 0.05 is equal to b cube. B is equal to, after we taking the cubic root of this, 0.9830. So now using the first and the second condition, we have the constant of A is equal to 0.7937 and the constant B is equal to 9830. And in this way we can go for the another question. For example, in this fifth question, the probability dense distributive function of a random variable is f of x is equal to, for the integral for the limit 0 to 1 is equal to x, for the limit 1 to 2 is equal to 2 minus x, for the limit x greater than 2, f of x is equal to 0. Find the mean and the variance. It's very interesting question. So first of all, mean. The mean formula for mean is equal to E of x. The E of x already we have the formula. For the continuous random variable, the formula for mean is equals to, here E of x is equal to minus infinity to plus infinity x f of x into dx. And we have the formula for variance is equal to E of x square minus E of x the whole square. Before finding the variance, the formula for E of x square is minus infinity to plus infinity x square f of x into dx. So in this, first of all, mean is equal to minus infinity to plus infinity x into f of x into dx. So instead of minus infinity to plus infinity, we can take the limits as minus infinity to 0, plus 0 to 1, plus 1 to 2, plus 2 to infinity, because there are 3 ranges are given the question. The limit is 0 to 1 is equal to, here 0 to 1 is equal to, the f of x is equal to x. Here x, the limit of minus infinity to 0. That is, there is no limit for the interval minus infinity to 0. So f of x is equal to 0 here. And the limit for x is equal to 1 to 2. For the limit of 1 to 2, the f of x is equal to 2 minus x. So instead of this, f of x is equal to 2 minus x. And this x is the formula, x into f of x. So f of x is equal to 2 minus x. And also x greater than 2 is equal to f of x is equal to 0. So x greater than 2, the limit is from 2 to infinity, f of x is equal to 0. So instead of this, f of x is equal to 0. So after the integration also 0. So we can omit first and the last integral. So we have to integrate first, second and third integration only. So here we can focus on the second integration, 0 to 1 x into x square into dx, plus, and for the third integral 1 to 2 x into 2 minus x, after the multiply by x inside 2x minus x square into dx. Now E of x is equal to, so after the integration of this x cube by 3, 0 to 1, plus integrate this with respect to x, 2 into x cube by 3 minus 2 into x into dx, x square by 2 minus x square into dx is x cube by 3, upper limit of x is equal to 2 minus lower limit of x is equal to 1. Hence upper limit minus lower limit, this is 1 by 3 minus 0, 1 by 3, plus as x is equal to 2 is the upper limit minus x is equal to 1 is the lower limit for this entire value, and we have the answer 1 minus 1 by 3. After the solving this, we have the answer, it is 1. Hence the value of mean is equal to 1. Next is the E of x square. Because of formula is variance. Variance formula E of x square minus E of x the whole square. So before finding the variance, E of x square is, this is the formula, minus infinity to plus infinity x square into f of x into dx. X square into f of x is equal to, here the same technique as before, whatever we had, 0 to 1 the f of x is equal to x, 1 to 2 f of x is equal to 2 minus x, and x greater than 2 f of x is equal to 0. So we can take the limit as minus infinity to 0, 0 to 1, 1 to 2, and 2 to infinity. And for the first and the last integration, the value of f of x is equal to minus infinity to 0, it is 0. And for this also, 2 to infinity also, the value of f of x is equal to 0. So consider the integration of the second and the third one. And here for 0 to 1, the limit is equal to x, f of x is equal to x. So already we have the formula also, x square. So x square into x is equal to x cube. And also for the next one, the integral 1 to 2 f of x is equal to 2 minus x, and the now 2 minus x into this x square here. So 2 minus x into x square, multiply inside 2 x square, here x into x square x cube. So the integrate now x here 0 to 1, x square into x is equal to x cube. So now, so the integrate and with respect to x and apply the limit as upper limit x is equal to 1 minus lower limit of x is equal to 0 for this integration, and upper limit of x is equal to 1 to 2, x is equal to 2 minus lower limit of x is equal to 1. In integrate, we have the e of x square value, and variance is equal to e of x square minus e of x the whole square. So we have the answer. And also we can prove the third question here. A continuous random variable which has the given limits are x is equal to 2 to 5 has a density function given by f of x is equal to k into 1 plus x. Find x less than 4. So we have the formula minus infinity to plus infinity f of x into dx is equal to 1. So instead of minus infinity to plus infinity, limits are given 2 to 5. So the given f of x is equal to k into 1 plus x into dx. Now take the constant k outside. So 1 into dx x into dx x square by 2. Apply the upper limit minus lower limit. So after the integration, which is equal to 1. Therefore, by solving this, k is equal to 2 by 7. Now we have the density cumulative distributive function p of x less than 4. So p of x less than 4 is the question. P of x less than 4. The actual formula for limits are given 2 to 5, but here x less than 4. X less than 4 means instead of 2 to 5 is equals to, here upper limit is equal to 4. So 2 to 4 f of x into dx. So now f of x is equal to k into 1 plus x. K value already we got it, 2 by 27 into this is the f of x function after the integration of x. So now 1 into x is equal to x plus x into dx is equal to x square by 2. Close the limit from 2 to 4. Upper limit minus lower limit. After, and to simplify, we have the answer 16 by 27. So this is the answer for this.